in motion will stay in motion, and an object in rest will stay at rest until come upon by an outside force. There are no outside forces in space. So if you can sort of see that little red box down there, on Earth, if we were to throw a ball at a wall, what would happen? The screen would go bye-bye, but what's supposed, I heard Sister Duncan say it, it's going to bounce back. The original path is changed. It's diverted, but in space, let's see if it'll work this time. Okay, no, there are no walls in space, so there's nothing to slow it down or stop any movement of any material. So what that means for us is that when this Big Bang happens, everything is going to lead from it and keep on expanding. Or should, if it's true. Let's see if I can get all three of these up. This is a new slide for everybody who saw my presentation yesterday. This is to explain the redshift theory, because I didn't have time to do that yesterday, and it's kind of an important part. This is how scientists measure the expansion of the universe. They take light from distant galaxies and measure the wavelength. So, say that's the wavelength at one time, and then a little later, because it expanded, the light waves get bigger. And what they do, they measure the difference between the top of the parabola and the bottom, and through the distance, they determine how far it's traveled. And what they do with that, they assume that the Doppler theory is correct. And the Doppler theory, we've all watched the weather, right? With the radar comes up, it makes pretty colors over the map. They measure how fast clouds are traveling so they can determine where storms are going to be. They use the same basic principle, however, that does not hold true in space, especially when we're talking about light, because we said earlier that light dilates time and space. So what is actually happening, this whole difference in wavelength could just happen with any light because it's dilating time and space so much that it actually grows longer by itself. So that does not necessarily mean that the universe is expanding, it just means that's the behavior of light. The conservation of angular momentum. This is sort of a weird kind of law. Angular momentum is a way to measure rotation. It's sort of like an angle, but not really. It's more of just how much something is rotating. The conservation of it means that it can't be created or destroyed. It just has to change forms a little bit. So that means that it's a constant. Angular momentum is a vector. There are two types of ways to measure anything in the world. That's with a scalar, which measures how much, or the magnitude only, and a vector, which measures how much and the direction, which means that it can be a negative or a positive. Pretty much is a vector. It's just, you can add a plus or a minus sign. All things in the universe must be spinning the same way if it came from the spinning ball of energy or the Big Bang, because of this conservation of angular momentum. It's all spinning the same way, and so that means that all the matter, which came from all this energy, must be spinning in the same manner. Let's see if I can get this in. No, I'm not going to get that animation. Okay. Yeah. It's a difference in PowerPoint versions. But what happens is, if we were to set this thing in motion, it's both of those balls are going to be spinning in the same direction. And if one was to fly off about there, it would travel in roughly about that sort of angle. And if one was to fly out there, it would travel in about that angle. So, Big Bang, stuff explodes, it flies off. What that means to us is if we connect those, it's still going to be traveling in that same rotation as where it started. Now, if the Big Bang holds true, we have backwards planets. Neptune spins backwards compared to the rest of the planets, and Uranus spins on its side, which, wow, I don't even know how that could have happened. In the beginning, if you're a God-fearing Christian believer, it's in the beginning God. If you believe in the Big Bang, it's in the beginning energy. Where did all this energy come from? And where did Text go? Must have been sucked up with all that other spin vortex. Anyway, where did all that energy come from? Well, it came from nothingness, supposedly. We have nothing. We have a room, an empty room, and you have no matter, no energy, no heat. It's at what scientists would call absolute zero. And supposedly energy was somehow just created, which breaks the conservation of energy, and we had an explosion. So, we're breaking my presentation and the laws of physics here. So, I'll try to sum this up pretty quick. So what we've learned is that we need a lot of energy to create a universe if we were going to make our own Big Bang. And we have to do it with nothing. Well, if you're in an empty room and you have nothing to work with, how are you going to give me an explosion? If someone can figure that out for me, I'd really like to know. I'll put it in my next presentation. And we've already talked about how we have backwards planets if we were coming from the spinning vortex of energy. So, what is all this? Oh. Well, okay, I'll see how far that goes. I had a picture of a candle, or a match head. Well, yeah, I had a picture of a match head being lit. And, you know, that releases energy. We have fire coming off of it. And so, with that fire, we have, you know, energy being released. But that's only chemical bonds. If we were to take all the energy and the atoms of every bit of that, just the match head, we could take out a nice-sized mountain range. So, you know, just throw a match and a crater. So that's just a match head. Imagine all of the energy in the room, from the boards, the floor, to the communion things, to the pulpit, to the speakers, everything. That's an enormous amount of energy. Google Plex's amount of energy, and I just wanted to say that word. So we have all that energy, and it has to be in a point smaller than what the eye can see. So having that in a single location is impressive enough, but having it that dense and compact, it all points to this can't be a coincidence. Someone has to be able to create all this, because what is the only thing unaffected by the laws of physics that we have proven time and time again to be true? Well, none of us can do it, none of nature can do it, only God can do it. He's the only one that can bend whatever the way He wants. And yet people who don't want to accept that have to make up theories like this that makes me have to do work and make presentations. So, with all these points, I hope you can take away today all that you've learned, or at least, you know, try to remember some of it, because these are the kinds of points and questions that other people around you are going to bring up. This is what the world's been taught, and they're going to wonder why isn't it this way, and so now you know why it isn't this way, and yeah, I think we can with that. So yeah, thanks for your time.